We'll begin with the body of the aircraft, called the airframe. The airframe is the basic structure of an airplane. Its main components include the fuselage, wings, tail assembly, and landing gear. The airframe is a lightweight underlying structure with thousands of specially formed corrosion and damage-resistant panels riveted or otherwise attached to it. The panels and airframe together make a very strong, relatively lightweight craft. Many of these parts, especially the outer panels, are made from a carbon fiber reinforced material. Traditional aluminum and aluminum alloys may also be used for these parts. Vertical frames support the crisscross sectional tube shape. These are connected by longerons that extend from the nose to the tail. In between the longerons is a complex network of stringers, intercostals, and subframes. The radome at the nose of the craft provides protection for the weather radar antenna below. Specific radio frequencies needed for the operation of the aircraft can pass through the radome. There's a double-layered bird strike barrier behind the radome to help protect the antenna. Floor beams attached to the vertical frames support the floor panels. Higher-grade floor panels are used in the cockpit or flight deck, as well as in higher traffic areas. Lower-grade panels are used beneath the passenger seating areas. Maintaining suitable air pressure begins with the airframe. Pressure bulkheads are reinforced metal barriers that separate pressurized from non-pressurized areas of the plane. Passenger planes usually fly between 9,550 and 11,580 meters, 31 and 38,000 feet above sea level. At that altitude, air pressure is 4 psi or lower. Humans are accustomed to about 14 psi. For that reason, most areas of the aircraft are pressurized during a flight. These areas include the flight deck and passenger areas, equipment bays, and cargo compartments. The radome, landing gear bays, the center wing box, and the tail cone are not pressurized. The wings attach near the center of the aircraft. A center wing box ties the wing frames together with the fuselage, with the keel beam providing additional support. A wing-to-body fairing is attached to the keel beam and two external longerons. The fairing encloses and reinforces this critical wing attachment point. Along the wing, two strong, flexible spars stretch from the center wing box to the wing tip. One spar is at the leading edge and one at the trailing edge of the wing. The jet engine is supported by a pylon that juts out from the wing frame. The connection between the pylon and the wing frame is extremely strong and extremely flexible due to the titanium links that extend from the wing to the pylon and the tension bolts that join the aluminum and titanium plates. Finally, at the rear or aft of the plane, we have the empennage or tail assembly, the structure that provides stability during flight with vertical and horizontal stabilizers. The tail requires additional frame supports and includes the tail cone, which contains the auxiliary power unit, or APU.